Okay, so this is example number, what is this? 7. And one of the things that is really, really important to notice as far as the polynomial that's under here is your exponents on your x's or your variables have to be descending, 3, 1, and then there's no x's, which is fine. But they also have to be consecutive. You cannot jump from a 3 to a 1 to a 0. It has to be 3, 2, 1, 0. 4, 3, 2, 1, 0. 5, 2, 3, 1. 5, 4, 3, 2, 1, 0. Has to be consecutive. So we're missing an x squared in here. And we can't do the division unless we have that x squared. So my first response is, cool, I don't have to do it. No, we have to add an x squared, but we can't just change the equation unless we add an x squared with a 0 in front of it, because 0 times anything is 0, so that means we're adding 0 to this polynomial. And we're allowed to add 0 to it since 0 doesn't change the value. So now we've got, whoops, 3. I'm going to have to erase that. Sorry. A 3, 2, 1, 0 x's. All right, now we follow the same rules. We figure out 2x goes into 4x cubed, and this time it goes into it 2x squared. Okay, again, see I put the 2x squared in line with this x squared. Okay, now I multiply 2x squared times negative 4. Gives me a negative 8x squared, so I put it again in line with all my x squares. Now I multiply 2x squared times 2x, and I will again always get 4x cubed, line minus 0 minus negative 8 is the same as 0 plus 8. Bring down my negative 6x. Okay, now I say 2x goes into 8x squared. 4, always put your sign there, 4x times. Okay, now I multiply 4x times negative 4, and I get negative 16x. And then I multiply 4x times 2x, and I get 8x squared, line minus. Negative 6 minus negative 16 is negative 6 plus 16, so that gives me 10x. Bring down the minus 11. 2x goes into 10x 5 times, because the x's cancel. 5 times 4 is negative 20. 5 times 2x is 10x, line minus. Negative 11 minus negative 20 is the same as negative 11 plus 20, which is a positive 9. And we stop there again because we're done with our numbers. We came to the end. So now I take that 9 and I put it up here and I put it over 2x minus 4. So that ends up being our answer. So one of the things that we could do if we wanted is if we multiplied this times this, we would get this. So I'm going to skip example 8. That's the exact same problem as example 4. They just did the long division for that. Well, maybe we should do that. It does have that x and y in it. So we'll just kind of go through it pretty quickly because then you can slow it down if you need to. Okay, so we take x into x squared. It goes x times. Now notice there's really no place to put it because I don't have, if I put it up here, sure, it gives me just an x, but it doesn't give me a y, so it's not in the same column. So when I do this, I'm just going to put it up there because it's the only place where there is just an x. So x times y is xy, and x times x is x squared. Negative 6xy minus xy is negative 7xy. I'm going to bring down the minus 7y squared. I'm going to divide x into 7xy, and I end up with the x's disappear, and that's all. Now I'm going to take the negative 7y times y and get negative 7y squared. And I've got negative 7y times x. So that's a minus. Those cancel. Negative 7 minus a negative 7y is the same as adding, which gives me 0, which means I'm done. Okay, this means that xy, x plus y, goes into this x minus 7y times. That means if I took x plus y and multiplied it by my answer, I would get this is an answer because this goes into this many times. So this multiplied together gives me this. So what this means is this x plus y is a factor of x squared minus 6xy minus 7y squared. It also means that this is a factor. Since there's no remainder, it means that it's a factor. It goes evenly into that. It's kind of like saying 6 is a factor of 12 because 6 goes into 12 twice with no remainder. Whereas if I had 5 and I put it into 12, it gives me a remainder of 2. So 5 is not a factor of 12, but 6 is, since it goes evenly into it. There's no remainder. This goes evenly into this. There's no remainder. And if I take this times this, I get 12. This times this, I get this whole thing. So later on, you'll find out how cool that really is. All right, let's jump to example 9 and we'll be done. Okay, so example 9, the first thing you're going to do is make sure you go 3, 2, 1, 0. If you don't, you're going to fill in the blank space with a 0, x, whatever exponent is on it. So just something to remember as you're going here. And what they're asking is, they're wondering if x plus 2 is a factor of this. Well, the only way you can find out if x plus 2 is a factor is to divide it by x plus 2 and get no remainder. If you get no remainder, then yes, it is a factor. So it says factor it completely if x plus 2 is one of its factors. So there's kind of two steps here. We're dividing. So x goes into x cubed, x squared times, whoops, I put it in the wrong place. X squared times 2 is 2x squared. X squared times x is x cubed. This is a plus, line, minus. 9 minus 2 is 7x squared. Bring down the 26x and its sign. X goes into 7x squared. 7x times 7x times 2, and then 7x times x squared. So 7x times 2 is 14x. 7x times x is 7x squared, line, minus. 26 minus 14 is 12x. Bring down the 24. X goes into 12x 12 times. 12 times 2 and then 12 times x. 12 times 2 is 24, positive. 12 times x is 12x. Subtract, we get 0. So yes, this goes evenly. Both of these go evenly into that. All right, but it says factor it completely. So this is factored completely, what we did here. But the answer is not. We still have a trinomial there that can be factored. So we get x plus 2. This can be factored into two binomials, I would imagine. 4 and 3 plus. Now it's factored completely. And that's it for 5.7.